What's up, guys? Hey, Devs here. We're back with some more LeetCode, of course. I think this is day 10 now. It's a pretty big milestone. I think for day 10, we're going to do some simpler problems. As you can see by my tabs, I was working on some math homework earlier and flashbang, and looking at some Java interfaces to kind of see. I was trying to do some harder problems and I couldn't figure them out. I figured one out, or I thought I figured it out. I could never get my solution to work, so we'll definitely come back to that problem. But it deals with reversing linked list, and I feel like if we do the reverse linked list problem, the easy one, it will help us overcome that one later, right? So it's all about incremental learning. You want to learn one thing before you hop into something else that requires you to know something, a previous algorithm, right? So we're going to start with the remove linked list elements. This is a fairly simple problem. I think it's simple because I've created, for one of my classes, I created a linked list. It felt like every week for a month, and I could program a linked list in my sleep. That's why I'm fairly good at these linked list problems. Anyways, we're going to hop right into it. We're doing problem 203, remove linked list elements. As you can see, it's easy. Yesterday we did a hard problem. My solution worked, but it was probably one of the worst solutions you could give. Someone in the comments was like, you could do this with bubble sort, make a fairly easy solution with bubble sort, and then you could also use a priority queue, which was the solution we looked at after. And both of those seemed like way better solutions than we gave. But I didn't want to use a priority queue because I don't know too much about the comparator interface or functional. I forgot. I think it's a functional interface. And then I don't know. I know a little bit about heaps and like priority queues, but not enough to program a solution. We may do that. Start learning that next time. As I've said before, day 14 is the day we're gonna switch around from linked list and go to something else, because we've been doing a lot of them recently. But so let's go ahead and get into the problem. So given the head of a linked list and an integer val, remove all the nodes of the linked list that has node val equal to val and return the new head. So here's the first example. So given a linked list 1, 2, 6, 3, 4, 5, 6, they want us to remove the value 6. So we'll need to iterate from this value to the next, and this value to the next, and then if 6 is equal to 6, we need to be sure to link 2 to 3, and that should be it, and keep up with this current node, because we need to make sure that, like in the 777 problem, we need to make sure that 3 isn't 6, so we won't iterate 2 again until we check 3. Yeah. Okay. This one's not too bad. So I think we're going to do, as you can see, I already attempted and solved this problem. So we're going to create a list node solution like we've done in many of our problems is equal to new list node. Or we'll give it a 0 and then make it point to the head of the list. And then we want to create a list node. Then we're going to do a previous. Well, let's just do current. So current is equal to the head. Okay. And then while the current does not equal null, we for sure want to loop over the list and iterate through it. And then we for sure want to return solution, not head. Right. So we could do. So we need to check if the current. Well, we could set solution equal to current. So we're going to check this I know what I want to do for this. So we're going to create a previous node and then a current. Why are my tabs funny? What did they do to me? My tabs are off. Okay, that's better. Now we'll create another list node called current. And set that equal to the head. Okay. While current's not null, we want to check if current.next is equal to, or current.val, not current.next. Current.val is equal to the current value, right? And so this will loop over our, let me get rid of all of that. So we have let me draw this out for you. Okay, so we currently have a node right here with the value 0. This is a temp node. It's not going to do anything for us, but it's just going to point to the head of our list, right? So we return solution.head. If there's no values that are repeating, it should return the first node and then therefore point to the rest of the nodes, right? So our previous is pointing to this node, right? And then our current is pointing to the first node of the list, right? So we're going to check that value if it's equal to the value, or check current's value and see if it's equal to the value we're looking for. Okay? And then if it's equal to that value, we need to reroute. Well, I can show right now. You see that we're looking for value 6, right? And 1 is not equal to 6, right? So we want to go ahead and iterate, not iterate, we want to go ahead and make a previous point to the next node and current equal to the next node if they don't equal each other, right? So we can check the next node. So we want previous to be equal to current, and we set current equal to current.next. And what this is saying is we are going to set our P is now going to be pointing to current, and then we're going to set current equal to the next node. So now they've been incremented by 1, and current now points to 2, and previous now points to 1, and now we're going to check the second value. We go through the while loop again because current is not null, and if current.val is equal to value, which it is not, since 2 does not equal 6, we want to go ahead and set, I think it's, yeah, so that, okay. So we know that 2 is not equal to 6, so we can go ahead and set current previous equal to current. So we'll just put that right beside here, and then we want to set current equal to current.next, and .next is the next node it points to. So current now is looking at 6. And then now inside this loop, we'll see that current.val is equal to value because, 6 is equal to 6, and 6 is the value we're looking for, right? And in this case, we want to set P's.next, so this pointer line right here, right now is pointing to 6 or current. We want to set that to current.next, so we want to go ahead and reroute it around the 6 to the 3, right? And then we want, after that, current is still pointing at 6, so we want to set current equal to the next value, which is 3. And we don't want to increment previous because we want to make sure that 3 is not 6 again. So you can imagine if this is a 3 and this is 6 again, we'll have to do the same algorithm and set this pointer equal to 4 and then move C over by 1, right? So all that to say, all that mumbo jumbo, we can go ahead and get rid of that. all that to say that we want to set current, or we want to set previous dot next. So this is the pointer of the previous node, which in our case would be 2. So this is our P node. We want to set current dot next, so the arrow, we want to set that equal to current dot next. And current dot next's arrow is pointing to 3. So we want to set that to equal to current dot next, right? And now that we have that situated, we want to go ahead and move C over to the next node. So we want C to be pointing at 3, so we can accomplish that by saying current is equal to current on next. That's easy enough. And we don't want to move P anywhere if the values are equal to each other, so we can check to see if 3 is 6 and continue. But I think that should be the solution. Oh, solution. I said solution dot head. No, you need to return solution on next, right? Do that. We get accepted. We submit this problem. And we can go ahead and get rid of this. It beats 94% with 1 millisecond runtime with a O of n complexity. And it has an O of 1 space complexity, or what do they say? Yeah, space complexity of O and 1, because we create just these 3 values. It's not dynamic, and then we create time complexity of O of n, because it loops over the entire list at least one time, right? Or worst case scenario. Which worst case scenario is going to the very end because it loops till current equals null. This is a very simple-ish problem, I would say. If you haven't dealt with linked lists, then this is not simple, but for the average person that knows about linked lists, this is a standard operation, is removing linked lists. And the hard problem I try to do today is we need to filter by linked lists. Filter by linked list, and we look at the linked list problems. Reverse nodes in k groups, right? So this is similar. You're reversing for k equals 2, you're reversing 2 nodes, and then you're reversing 2 nodes, and then if the last isn't 2, you don't reverse it. And you can see my failed solution here. I feel like it would be useful if we go ahead and learn how to reverse a linked list, right? Because reversing k nodes is just shrinking this problem down, and you're doing it multiple times over the entire list, versus this is just doing it once. And the best way to do this is probably to we can go ahead and erase all this. So if we have a current pointer equal to the 1 value, right? And then we have a next pointer. We want next to be equal to c dot next, right? Not good at drawing with a mouse, but there we go. So n equal to c dot next, so n will end up pointing to the 2 value, right? And since we're reversing it, we want the 1 to be pointing to null. So we can set the, we can just call this previous, kind of go along with ours. So we can set p equal to null at first, right? And then what we want to do is we want to break this link because c's dot next is equal to 2. So we're going to set the next node equal to c dot next, and then we want to set c dot next equal to p. So we will break this link and have it now pointing to null, okay? And then after that, we want to link not n. We want to set c equal to n. That way we can, because we can't say c is equal to c dot next because we broke the link. But good thing we kept up with the next link with the next node. We want c to be equal to n. So, well, n will still be pointing to this, but we want c to be now pointing to 2. Actually, the first thing we want to do is we want to increment p, right? So we want p to be equal to c. So we'll increment p, bring it here. And then we want c to be equal to n. So then we take out n is to set c as that. And then we want to set, we don't want to set the c dot next yet to null until we set the the next node equal to 3 again, and then we're going to complete that, repeat the algorithm over and over again, right? So we can do, well, we only have to keep up with the previous, so we want a list node previous is equal to null. We want list node current is equal to head, and then while current is not equal null, we want to do like we said. We want to set a list node next equal to current.next, right? So this statement right here is, so we can go through this algorithm one more time. So we set previous to null. So this points to a null character. C is pointing to head, which is the head of the list, right? And then we want next to be pointing to the next value, okay? And the first thing we want to do is go ahead and break, we're going to go ahead and break the link that they hold between C and next. So we want current.next to be equal to previous, right? And then what that does is it breaks this connection, and then now we're pointing to the null character, or the previous node, right? And then from there, we want to set p equal to c, and then c equal to n, okay? So from there, we can set previous is equal to current, right? So what we did is p is no longer pointing to null. P is now right beside c, okay? And then after that, we want to set current equal to next, right? And then now c is no longer pointing to 1. C is now pointing to 2. And then n, once we break out of the while loop, it will lose its scope and therefore be in the garbage collector. And then we will set a new next is equal to current.next. And then we'll loop through this again, setting next equal to the current's next. Then we want to do the current.next. We want to break this link and set it equal to p, right? So now we've established a new link in the reverse order. So now currents.next is now equal to previous. And then after we've successfully broken the link and relinked it, we want to set p equal to c. So p will now be down here. Then we want to set c equal to n. And then when we break out of the loop, this will be broken. And then the next loop iteration, we'll do n is equal to here. So on and so forth until we get to the very end. So when we get to the end, we will when we get to the end, we'll have n is equal to here, c is equal to here, p is equal to here. We want this link to be is already broken. We want c.next to be equal to n, so n's over here. And then c's.next, so we want this to break this link and then reestablish it, set equal to previous, and then the previous nodes are already linked together. And then this is pointing to a null character, right? And then after this, we want p to be equal to c. P is no longer over here, and then c to be equal to n. And then this is already pointing to a null, right? So the next loop iteration, we're going to have the next pointing to the null. Then circle that so you know this is a null node. And it should work the same exact way. We want to break this connection. We want to set c's new connection to the previous. We want to set p equal to c. So p is now pointing to 5, and then we want c to equal to this. And then as soon as current is equal to null, we know we don't have another node to link back up, so we can break out of this, right? And this should give us the solution we want. Oh, no, I have not returned anything. So if you saw there at the end, right, p is pointing to the last node in, or the first node in our new linked list. So all these are pointing backwards now, all the way to a null character. And so we want to go ahead and return the previous. And we submit that. There we go, all the test cases run successfully. And if we go ahead and submit that to the LeetCode test bank, 28 out of 28 passed, 0 milliseconds, beats 30%. So this has a time complexity of O of n, and then it has a space complexity of O of 1 because there's no dynamic creation of objects, and there's also no and it also loops through the array one time and then returns the new head of the array, right? I feel like these were pretty good problems, kind of refreshers on some basic operations we do on list. So if you ever want to reverse it, this is a fairly good algorithm. And if you ever want to remove a list, this is also, I feel like, a fairly good algorithm. You keep up with the previous and the current. And then if current is equal to val, you set the previous, you want to relink them. So you want to set the previous equal to the next node. And then you want to set current equal to the next nodes, so we can check this. And then if it's not, you want to go ahead and increment previous and current to the next two nodes. These are fairly good. This will help us in the future for the k-nodes problem. And these were easy versus yesterday's hard problem. We did 2 easy problems. If you have any suggestions for any problems you would like me to do next, or the way I do my videos, anything you'd like to see, I do plan on creating some type of project after this semester of school, or maybe like before exams. I'll probably brainstorm what I want to create, and then this winter I'll probably try to create something and produce it, and then be sure to ship it. Like, I want to ship it somewhere, I want to have it in production, I want other people to use it, I want it to be usable by other people, right? And that would be good on job applications. You can show that to any of your employers. It's good talking points if you created something by yourself, right? And we'll also need to start using GitHub for our projects. GitHub is huge in the tech space. It allows you to keep version control on all the code you make. So if you implement a detrimental bug, you can just revert it back to your previous commit, or one of your previous commits. So it allows you to incrementally program, and then also if you mess something up or change something too bad, or if you want to also test out new problems, you can branch off from your original. So we're going to try to make videos on Git, make videos on projects that we create, while also doing LeetCode. While I'm doing a project series, I probably won't do as much LeetCode. I feel like this is good while I'm at school and taking classes, because it takes me about 30 minutes to an hour to find problems and find solutions for them, and then about another 20-30 minutes to record them. But also, a little side note on the actual YouTube channel. If we go and check it out once again, the last time I talked about how the YouTube channel was doing, we only had, I think, like 47 subscribers, but now we're at 61, and it's day 10, so that's, I mean, hitting over 50 in 10 days, I feel like is a pretty big deal, at least to me anyways, especially over something niche like programming and solving LeetCode problems. I don't feel like the target audience is as wide as creating like kid video gaming content or health and wellness or like mukbangs, I feel like there's a very niche subset of people that actually are interested in programming and how computers work, stuff like that. But I'm very thankful for all the nice comments. I mean, there's just been bajillions of, not bajillions, it feels like bajillions. There's at least 3 or 4 a day that I get to read, and they're always super nice. I haven't got a hate comment yet, except for my friends that I showed my channel to. They always had something to say, but it was all out of the kindness of their heart. I promise. They were just messing around. But so this is day 10. We got 9 videos. We got until I get a job to go. So if that's a year, that's going to be over 350 LeetCode problems or 350 videos. And I'm hoping by a year, if we hit over 350 problems, by then I will have the knowledge sufficient enough to be able to get a job, or not maybe get a job, but if I get in an interview situation, I should be able to solve any problem they have coming my way. And this is also helping me refresh on my Java basics, Java control structures, and a little bit about objects with the list nodes, of course. A few of the problems we've used Java's interfaces on lists, sets, stacks, and their queues interface. So that's also a great refresher on their different data structures they implement in their classes. I have been reading a Java book in order to learn a bit more about the basics of Java. I mean, the first like 6 chapters were refreshers, and now we're finally getting to objects, and we already got into objects, then we got into in arrays, and now we're getting into more on classes and objects. So I would like to see what the people that wrote the book think about classes and objects, about creating your own classes and objects. And anyways, I'm kind of rambling on here, but thank y'all for watching. I hope y'all stay blessed, stay healthy, and I'll catch you on the next one. Hey Devs, it's out.